A pleasant greetings to all. In this video, I am going to explain effect of impedance on symmetrical components. Effect of impedance. We can write the relation between phase voltage and current as VABC equal to ZABC into IABC. What is ZABC? 3x3 matrix giving self and mutual impedance in and between three phases. And what is VABC? VABC is the unbalanced voltage, and in the previous video have explained the relation between unbalanced voltage and the sequence component of the voltage. I have given in the description box. Okay, now I am going to write VABC. VABC is what? How we can equate VABC with V0, 1, 2. 0 means 0 sequence component, 1 is positive sequence component and 2 is the negative sequence component. This is the unbalanced voltage. In the similar manner, I can write the current also. IABC is A into I0, 1, 2. Instead of VABC, have to write A into V0, 1, 2 equal to ZABC matrix into I0, 1, 2. Then multiply both with A inverse. So A inverse into A, V0, 1, 2. In the right hand side, A inverse matrix is at ABC into A matrix IABC. So what is Z0, 1, 2? That is equal to A inverse ZABC into A. Next I am going to explain sequence impedance of star connected loads. Figure shows three-phase balanced load connected in a star. The load has self and mutual impedances. The star point is grounded through a impedance Zn. Here what is Z as? Self-impedance. Zm is a mutual impedance between two phases and Zn is the neutral impedance. So VA, VB, VC are line to ground voltages. And what is the current? This current IA and this is the current IB and this current IC. And this is the neutral current. Next, for the same circuit, I am going to write the equation. So VA equal to, see, I draw the circuit now. So here it is connected to the neutral impedance Zn, Zs, Zs, between this Zm, between these two phases Zm, these two phases also Zm, Zm, VA, VB and VC. So from KVL, VA equal to Zs into IA and Zm into IB and Zm into IC, okay, plus Zn into In. This is the equation for voltage VA using KVL. And then VB Zm into IA. Here VB is a phase connected with VA by means of the mutual impedance. So Zm into IA plus Zs into IB, this is self impedance, then Zm into IC plus Zn into In. What is VC? VC is Zm into Ia, then Zm into Ib, Zs into Ic, Zn into In. Now what is the neutral current? So these are the currents Ia, Ib, Ic, and this is In. So sum of the current flowing towards the junction is current leaving from the junction. So from Kirchhoff's current law, In equal to Ia plus Ib plus Ic. Then I am going to substitute this In in the equation A. Va equal to Zs into Ia, Zm into Ib, Zm into Ic plus Zn into Ia plus Ib plus Ic. So what is Va? Zs plus Zn. Zn in Ia, no? So Zs plus Zn, the common current is Ia. Then Zm, again Zn, the current is Ib. Then the third one, Zm plus Zn into Ic. So these are about the voltage Va. Similarly, what about Vb? Vb is Zm plus Zn into Ia. The center one, self-impedance Zs plus Zn plus Ib. Then last one is Zm plus Zn into Ic. Then what is Vc? Zm plus Zn into Ia plus Zm plus Zn into Ib plus Zs plus Zn into Ic. These are the voltage equations obtained for the star connected load. Next, I am rewriting the same equation. Va equal to Vb equal to and Vc equal to. Then I am going to write in a matrix form. Va, Vb, Vc. Here how to write the Z matrix? The first element is Zs plus Zn. Second, Zm plus Zn. Third, Zm plus Zn. And next, second row, first column, Zm plus Zn. Then Zs plus Zn. Third one is Zm plus Zn. Next, for the third column, the third row, Zm plus Zn, Zm plus Zn, Zs plus Zn. And next, I have to separate this Z matrix. So, ZABC is Zs plus Zn, Zm plus Zn, Zm plus Zn, then Zm plus Zn. Have to write like this. From the above value, we can calculate the Z012 by Z012 equal to A inverse ZABC into A. Z012 equal to 1 by 3. What is A inverse? 1 by 3. 1, 1, 1, 1, 1, A square, A. And next put the ZABC value. Already we have derived. And next put the A value 1, 1, 1, 1 A square A, 1 A square. Next, what I have to do? Multiply the second and third matrices first. So, Zs plus Zn plus Zm plus Zn plus Zm plus Zn, that is equal to Zs plus 2 Zm plus 3 Zn. And next, Zs plus Zn plus Zm plus Zn into A square plus Zm plus Zn into A. So, Zs plus Zn of 1 plus A square plus A, because all the columns consist of Zn. And second and third column consist of Zm. So, Zm of A square plus A. And then Zs plus Zn into 1 plus Zm plus Zn into A plus Zm plus Zn into A square. Here also is only one Zs plus Zm. How many Zm? 2 Zm. One is corresponding to A and another one is A square. So Zm of A square plus A, and the three elements consist of Zn. So Zn of 1 plus A square. In this way, have to complete remaining element in the matrix. Next, Z012 equal to, have to reduce this matrix by applying suitable expressions. So the first one is 1 plus A square plus A equal to 0. From this, what is 1 plus A square? That is minus A. From this, what is 1 plus A? That is minus A square. What is A square plus A? That is equal to minus 1. Instead of these values in the matrix, you have to put 0 for this, minus A for this, and so on. So the second term consists of second element A12. For example, Z12. So A square plus A equal to what? That is minus 1. 1 plus A square equal to 0. This term vanishes and Zs minus Zm is obtained. In the similar manner, Z13 equal to Zs minus Zm. The third term vanishes. And next, in the similar manner for the second row, second element A square into Zs minus A square into Zm, and third term is 0. So take A square is common, Zs minus Zm. The third also A into Zs minus Zm. And the third row element, the first one is there is no change. And the second element A into Zs minus Zm. And the last element is similar to this element A square into Zs minus Zm. Next, I am going to multiply this matrix with this matrix. So, what is the answer? That is 3 into, have to multiply this with this. So, 1 into this term plus 1 into this, 1 into this. All the terms are same. So, I can write like this 3 into Zs plus 3Z10 plus 2Zm. And this 1, 1, 1 is multiplied with these three. So Zs plus A square plus A, this is reduced now. So Zs minus Zm plus A square into Zs minus Zm plus A into Zs minus Zm. So summed up all the values. And the third column is multiplied by row number 1. So 1 into Zs minus Zm. Next 1 into A into Zs minus Zm. Third 1 into A square into Zs minus Zm. Now summed up all. Next, take the second row is multiplied with the column number 1. So the elements of same. So into 1 plus A square, we can write like this. And here also 1 into Zs minus Zm plus A into A square. Okay, A into A square, that is A cube. Then A square into A, again A cube. 1 plus A cube plus A cube. And next, Zs minus Zm, 1 into Zs minus Zm plus a square into a, that is a cube. Sorry. A into a, that is a square, not a cube. Then a square into a square, that is a power 4. So second row is obtained. The similar manner, third row elements are here a square, a power 4, a cube, a cube. So what is a cube? A cube equal to 1. What is a power 4? We can write a power 4 as a cube into a. That is a. So I can write a. So 1 plus a square plus a power a. Sorry, a power 4 is equal to a. So this is equal to 0. And this is equal to Zs minus Zm, 1 plus 1 plus 1. So 3 into Zs minus Zm. Here fully 0. This is 0. And this term also Zs minus Zm into 1 plus a square. Also 0. Here 1 plus a plus Zs minus Zm into 1 plus a square. This is also 0. And this is equal to 1 plus a square plus a. This is also 0. Here 3 into Zs minus Zm. Okay. Here a cube. Now this equation is reduced as Z012 is Zs. Already 1 by 3 is there. No, the 3 get cancelled. Zs plus 3 Zn plus 2 Zm. Here 3 into Zs minus Zm divided by 3, that is Zs minus Zm. Here also 3 into Zs minus Zm divided by 3, that is Zs minus Zm. This is the final equation for Z012. From this, we can conclude the point number 1. Symmetrical components of impedances are independent of one another. There is no coupling exists among 0, positive and negative sequence impedances. Second one, positive and negative sequence impedances are equal. Both are Zs minus Zm. Third point, 0 sequence impedance is approximately 2.5 times that of positive or negative sequence impedance due to different magnetic field set up by 0 sequence current. Fourth point, if mutual coupling is negligible, all the sequence impedances are equal. So first one is Zs plus 2 Zm plus 3 Zn. 0, 0, Zs minus Zm, 0, 0, 0, Zs minus Zm. For example, if no mutual coupling, that is Zm equal to 0 and ground impedance is 0, we get what answer? Zs 0, 0, 0, 0, sorry 0, Zs 0, 0, 0, Zs. That's all. Thank you. Have a nice day.